All right. Hello, everyone. Make sure you go and if you haven't already, sign up for the register to that workshop URL, that link that I dropped in the chat. You could go there and it'll send you the link to the materials. So if you haven't done it, go ahead and do that now. All right, let's go to the next slide. Okay, so this is essentially what we're going to be covering. It's going to be a two-part series, a data science series, where we'll be gathering data, and then we're going to be analyzing the data. And this particular workshop, we're going to do more so focusing on the gathering aspect. We'll look into the analyzing part a little bit with Seaborn towards the end. But essentially, at this point, we're going to just try to get the data off of Amazon. So a few products from the Amazon website. And then make sure as well, the link was there as well, but make sure you sign up for Hackathon. You should try to go to the HackUTD that's coming up. So if you haven't already registered for that, go ahead. I'd really recommend you guys to take part and try it out and just get the experience in on there. All right. So what is web scraping, right? So you can look at it two different ways. Web scraping, it's kind of like one of those things that you could manually do. You can do it by hand, but more times than not, the type of data that you're trying to get, the quantity of data that's useful, it ends up being a little bit out of reach of what you could do manually. Because you can go online, you can go and manually open up a spreadsheet and just start pulling data. But the problem is once you start getting to excessive numbers, it just doesn't seem feasible. And so what web scraping kind of takes care of is getting that data, but through like a script. So like batching it. And this way you can get like thousands or large numbers of values that you can pull without having to tediously do each page at a time or each product at a time. You can do it. What it could do in a few seconds would take you hours, days. So it's automating a process that would take us as humans so long to do. And so the other part of it is a formatting. So you can format the data without actually having to do a lot of the work manually. If you already pre-designate what data you're getting, you can output it the way you want it as well. So those are the two benefits of web scraping. Next slide. Here is 3 different sections. I kind of broke this up a little bit to kind of give you a broad idea of how and where and what type of data you would end up getting through web scraping. So to kind of give you an overview on it. So like if you want to focus on the results, I think that'd be the easier way, and then kind of look backwards. So you can create a database of business leads, and who would use that? Well, it would be businesses. So like I would say real estate companies may need a database of homes, for example. And then that they can aggregate the available homes for that first one. Or another bigger one is like from the enterprise aspect of it, if you want to think of like Kohl's or one of those brick and mortar companies that have point of sale. So they want to keep track of data activity that's happening inside their stores. And so they're going to monitor the sales data to try to prevent potential fraud and unusual activity. So those are 2 kind of like big ones you can kind of wrap your head around that makes sense. And so the benefits to it is that you can do a lot of real-time data analysis through that and then take action immediately. But also more so than anything, like for example, with stocks, if you aggregate enough data, you can make a better decision based on history. So, okay. All right, and then ethics of web scraping. So there's 2 sides of this. It's a little murky. It's kind of in a gray area. So it just depends on the data that you're collecting and if it's permissible to collect that data. And so you do have to be careful on what you're getting. And the big markers to know is if it's public, you could probably scrape it, but you should keep in mind that certain websites have certain, they're called robots. So if you keep track of the robot text file, it'll tell you exactly what they will and won't let you access or what they're permitting for you to download. And one key court case that I wanted to point out was the HiQ versus LinkedIn. Essentially, HiQ was offering up LinkedIn users' information that was publicly available and trying to sell it to the employers. essentially trying to call people out that were looking for another job possibly. And LinkedIn was ultimately kind of working on the same type of product. And it kind of seemed like they ended up putting a blog against HiQ because they were trying to play the moral high ground. But ultimately, the court case ruled with HiQ because at the end of the day, it was still scraping public data. So it's kind of in a gray area, and it just depends on how it's interpreted by the courts. So just be careful about that.
Hi. So what is Scrapy? So Scrapy is an open source software that is written in Python. It is a full-size framework that is built for web scraping and web crawling. So as Rolando discussed earlier, web scraping means extracting publicly available data from the web. Web crawling is a related concept which involves using the extracted data to find additional sources for related data. Scrapy makes it easy to get structured data from online websites and even APIs. In this workshop, we will use Scrapy to get product reviews from Amazon.com. We will also learn how to export the data in a structured format that makes the data easy to visualize and analyze. Step 1 to using Scrapy, you have to download Scrapy. So in the pre-work for this workshop, we provided a tutorial on downloading the libraries that you will need tonight. In case you missed the pre-work, please download these libraries right now. If you're having trouble following the pre-work, please ask your questions in the chat. So that was step 1, downloading Scrapy. Once you have Scrapy, you should be able to access the Scrapy command line interface. So it installs some commands into your command line for your computer. You should be able to access those commands from your terminal, which may be called CMD or PowerShell in Windows. But steps 2 to 4 list the commands that you need to set up and run a Scrapy project. I've provided them for future reference, but I've also already configured them in the workshop material that you should now be able to download from the link tree that you got from the sign up at the beginning. So you don't have to worry about steps 2 to 4 for now. Does that make sense to everyone? Is that good? Can everyone hear me?
Yeah.
Can I get some yes in the chat? All right, cool. So getting deeper into Scrapy. So let's see what Scrapy can do for you, right? So if you tell Scrapy the link of the website that has the data that you need, it can send a spider to visit that website. I mean, not a literal spider, but a spider here refers to a Python program that we will code soon in this workshop. This spider program sees the web page differently than humans use. So like we would see the web page like this, like we would see the graphical user interface of the web page, but the spider, on the other hand, actually just receives a copy of its HTML code, its CSS code, and its JavaScript code, like the one over here. So Scrapy provides an inbuilt HTML parser that you can use to interpret web pages. In this workshop, we will use an alternative for parsing library called Beautiful Soup because I think it's easier to use than Scrapy's inbuilt parser. The parser is basically responsible for converting HTML code into a hierarchy of different elements that compose the web page. This makes it very easy for us to find specific parts of the web page that have relevant data. Like here, you can see that the title division contains the name of the product. So I can get Scrapy to scrape data from this specific division while ignoring other data around it that we are not interested in. So pipelines. Pipeline is another type of a program that you can write using Scrapy. Basically, when you export some data from a parser, Scrapy sends it through some default pipelines, and you can also define custom pipelines based on the requirements of your project. And we will define a custom CSV pipeline for this project soon. So next, when it sends it through a pipeline, after that, it lets you structure and format this like chaotic HTML code that the website sends you into like a nice looking structure. And it also allows you to validate these entries that you're exporting. So once you have structured and formatted the data, you can export this structured data in a file format of your choice. For this tutorial, we will use CSV files. That is comma separated values. So CSV files are easy to export and they're very easy to read using Excel, or for example, maybe another Python program that could help you visualize that data. So also, if you're comfortable with using databases, then you can also connect like a SQL database with Scrapy, or maybe even a NoSQL database like MongoDB. All right. So does that make sense to everyone? Like basically what Scrapy does here. All right. So what else do what else do spiders do? Can anybody in the chat tell me what do spiders do? Like make web, yeah, they make web, and then what do they do with that web when they make that web? They crawl it. Nice. So basically, let's say you go to Amazon and you're searching for some gaming PCs. Now, Amazon might suggest you some like keyboards and like mechanical keyboards and mouse and other like related entries, right? So a Scrapy spider allows you to easily visit such related links. So also like at the bottom of the first page of search results, you may find links to like page number 2 and page number 3 and so on. So here's what Scrapy does. It allows you to crawl from the first page that you visited to basically any other related pages, like pages for links to mouse, or maybe page number 2 of the search results, or like page number 3 of the search results. So basically, spiders provide a very intuitive way of programmatically browsing through multiple pages when like the data source that you're scraping isn't just like one page and there's like a bunch of different pages. Scraping can be like very helpful. So if everyone got a basic understanding of what we're doing here, now I would want everyone to go to that Linktree link that you got when you signed up for the workshop in the chicken slide. And click on the code skeleton. And that should bring you to this GitHub repository over here. Now, if you're familiar with Git, you just want to pull this repository to your computer so that you can work on it. If you're not, just click on the name of the repository to get to the root, and then click on this green button to download the code and then you can click download a zip. So that will download a zip file to your computer. Make sure that you extract that zip file. All right. So can I see some hands in the chat? Anybody downloaded the code? Are we good here? All right. Cool then. Now let's open this folder in a text editor of your choice. So what kind of code editors you prefer. Just whatever you like. If you like VS Code, you can go to VS Code. If you don't have one right now, please download one right now. You can use any ID of your choice for this tutorial. We don't really have a preference on that. But if you're using VS Code, I've already set up a bunch of stuff in VS Code, so you won't have to worry about it. So open your IDE and click on Open Folder, and then navigate to this folder that you just downloaded, the GitHub repository. And inside that, you would see a code folder. So don't open that folder, but just like click on the arrow or like double click it to like enter that folder, and then make sure that this Amazon_scraping folder that is directly under the code folder is highlighted, and then hit open. So over here, make sure it's code and then Amazon scraping. So once you open that folder, you should be able to see a folder structure like that. It should have the .vs code folder. It should have a run.bat file, a run.sh file, a scrapey configuration file. So this is basically the folder that you want to open. If you open the wrong folder, then you would have trouble later, like when you're trying to like build it or something. So make sure you're opening the right folder. Next, there's this very cool extension in VS Code called ToDo that you can install, and it might be helpful during this tutorial because the tasks that we're going to do are structured as like to-do comments that get highlighted by this extension, but it's pretty optional. Now, you should be able to see all the code that we've already provided, the basic skeleton code that you're going to fill in. And at the top, if it looks like this, if it's all good and there are no squiggly lines, if you're not getting any errors, that means you're good. If you are, then there's a possibility that the libraries that you downloaded were not properly downloaded or linked, and you should try to fix that right now. Ask your questions in the chat if you're having trouble. All right, so looks like we're done opening the project, right? Has everyone been able to do this? Are we good here? Just want to make sure nobody opens the wrong folder or doesn't have the libraries or anything. All right, so looks like we're good. So let's move on. Now, if everything is working fine, then you should be able to go to terminal and then run build a task. So let's do that. I'll go to terminal and then run build task. And it's going to just give me some errors, but at least it ran. That means that the build pipeline is configured fine. If anybody's on Windows, it's possible that it might say I didn't find or like I can't run a command that's like /run.bat. In that case, just go here, choose your select default shell, and then change to PowerShell, and then you should be able to run this command correctly. So was everybody able to build this project with these errors? Oh yeah, unable to import. Yeah, you're probably seeing a different error, but yeah, at least it built and you got some errors. That's where we want to be right now. We're gonna fix those errors one by one pretty soon. So all right, now let's start fixing those errors. So the first file that we're gonna visit is settings.py. It's in the Amazon scraping folder that is under the Amazon scraping folder. For some reason, Scrapey names both of these folders the exact same thing. So you can go to settings.py, and here one of the things you might notice is that I've said robots.txt. rules, and I've set that option to true. So what that means is that our scraping bot will obey the rules of the robots.txt file to try to keep it more ethical. And additionally, I have used auto throttling here to slow down the speed of our bot so that it also doesn't put a lot of load on Amazon server. Um, but over here on line number 43, what we're trying to do is that we're trying to use the headers, the HTTP headers that normally your browser would send to Amazon.com, and we're trying to use those headers for making these scraping requests. So the thing is that I have not included headers.json here. That is why it's giving an error, but there is a headers.backup.json file, and Scrapy is not recognized as an internal or external command. So Pages, maybe you had a problem installing Scrapy or linking it, or for some reason like the command line interface is not available. Try reinstalling Scrapy. But as I was saying, I want everybody to rename this headers.backup.json to headers.json, or you can just create a duplicate and then rename it. Just make sure you change the headers backup to just headers.json, and so we're going to provide the code for this workshop. I'm not sure if we're recording it or not. But did everyone reach here? Was everyone able to get here and rename their headers file to like headers backup to headers.json? Can I see some yes in the chat? All right. Looks like some people got it. So let's move on from here. So now in headers.json file, you might see on line number 5, the user agent string is set to empty. So let's talk about what all these strings mean. The accept string is the list of different formats that our application can accept. Accept encodings are the different encodings that it can accept those formats in. There's also accept language. That is because HTML pages are usually like in a specific language. So this is like what kind of languages are we accepting? And then the last one is user agent. So what is user agent? That is a question that I want everybody to Google right now, exactly like this, without any capitalization or question marks. Just Google, what is my user agent? When you Google that, you should probably see it. Google will tell you if it doesn't, try to open the first link and you'll find it. Copy that user agent and paste it between those two quotation marks on line number 5 next to user agent. So Google, what is my user agent, and copy paste it. Now let's talk about what the user agent header is. So if you see your own user agent header, you'll be able to tell that it has the name of your operating system and like the version of your operating system, and like the name of the browser that you're using and the version of the browser, and something like a browser engine, for example, which could be like WebKit, and like the version of WebKit that you're using. So before we proceed, it is very important that everyone has this part fixed. Otherwise, we will not be able to move on. So was everyone able to copy their user agent string into the headers.json file? Or are we getting a lot of errors getting to this point? All right, I see some yes. Got it. Yeah, I just want to make sure that the majority of y'all are on it, because this is a very essential step right here. All right, cool. So at this point, if you try to compile again, if you were, correctly renamed your headers file and you put your user's agent string in there and everything, then you should not see an error anymore. I mean, you shouldn't see that same error. You're probably going to see a different error because there's still a lot of part of the code that we haven't written yet. So let's move on. Next up is defining the data structure that our application is trying to scrape, which we define in the items.py file. So you might notice I created two classes, one for product, one for item, for reviews of these products. And I put some fields in each of these classes. Let's talk about how they work. So in product, I basically want to know the name of the product, and I want to know like the price of the product, and I want to know like what are the average number of stars from their reviews, and I want to know like what is the serial number of that product that Amazon uses so that we can properly store it. So these are some of the things that I want to extract. And I also, for each product, I want to extract like a list of reviews, like an array of reviews. And each of these reviews would have a stars field and a description field. So like the number of stars that this product got and what was the description for that review, like why they gave us 4 stars or 5 stars. But as I said, for this in this workshop, we're gonna export the data as a CSV file. Now the problem with CSV files is that they're like 2D and they're like flat. So corresponding to every row and column, you have exactly one cell, exactly one entry. You cannot put like a list of reviews corresponding to reviews, So what we're gonna have to do is we're gonna have to export products separately and export reviews separately. So we're gonna have to delete this reviews array. So it's no longer gonna be a member of the products class. We're just gonna export these two things separately. But then the problem arises that how are we gonna relate those two? How are we gonna know that this review relates to that product? If anyone has worked with databases before, any clues on how we can do that? Anybody know? Yeah, like in a relational database, how would you object ID? Yes, perfect. So here our object ID is the ASIN. So we're also going to store the ASIN in the reviews so that you can relate them. And then this is what our output would kind of look like. So you might notice there's an output directory in your project, and then in output there's products and there's reviews. So in the product subfolder, we want to export like lists of products, and which is just going to have basic information about them. And then, but it's going to include their serial number, their object ID. So related to this object ID, we're going to have a file in the reviews folder, which is going to have the exact same name as the ASIN from this product, which would tell us that these are the reviews for this Alienware or our R10 gaming desktop. And additionally, if you want to extend this concept and if you want to, have different lists of products for the different keywords in Amazon that we search for, like gaming PC or mechanical keyboard or something like that, then we can also include a keyword as part of our class and use that for naming. So this is basically the structure that you'll see in items.py. Anybody have any questions on that? Are we good here? So yeah, somebody said they don't see reviews. That's because I deleted reviews because it was an array and we cannot export an array. So we're going to use an alternate way to somehow relate these two. So let's see how we're going to do that, right? So as I said, you can write your custom pipelines in Scrapy, and we're basically going to use a pipeline to accommodate this kind of exporting, because by default, Scrapy only exports one single file. It doesn't export like, multiple files into multiple directories the way that we want it. So what I've done in the code is in the pipelines.py file, I have declared this CSV pipelines class. This is just like an abstract base class. It's basically something that has generic code for exporting data in the structure that we want in like a CSV file format. But you have to derive it and basically create child classes that are derived from this CSV pipeline based class for your own item types. So for this tutorial, I've already defined the product type and the review type. So let me show you how I extended those. Basically, whenever you're extending, you gotta pass it some of the parameters that it needs in its initialization function. So let's talk about those. The first one you see is like item type. That is the class of the items that we're trying to store. So I have two pipelines, the product pipeline and the review pipeline. So two pipelines, one each for each of the two data types that I had. And in their item type, I basically passed the name of the class that has their data type. And then fields is like an array of the fields from that class that I finally want to export, that I finally want to display in these Excel sheets. So ASIN, price, average stars, and name were the 4 things that I wanted to display in the CSV file. So that is why those were the 4 fields that I mentioned here. In case of reviews, I mentioned stars and description because those were the 2 I wanted. And then a key field takes the unused parameter, the parameter that is hidden, the one that we don't want to show, but we still want to use for our file names. So in the case of product, that was the keyword. The keyword that we search is used for the file name. And in case of review, that is the ASIN, that is the object ID or serial number that is used for the file name. So here we have keyword and here we have ASIN, just the field that we want to use for file names. And then there's the output directory. So that is like the subdirectory of the output folder where we want to export this. Here it's products and here it's reviews. So products and reviews. The reason why I wanted to explain to you how I did that and how I derived it is because this kind of structure can be very helpful and you can use it in the future. You can just use this pipelines.py file that I've created and it'll do that for you. But in the future, of course, if you have another project, you would have a different data structure, right? So in the items.py file, you would define a different data structure. So corresponding to those, you'll just have to come to this file and also derive those corresponding child classes from the CSV pipeline class. But for now, I've already coded it to make this a little bit easier and so that we can focus on the spider code a little bit more. But do pipelines make sense? Does it make sense? What I'm doing here, what do these fields mean? And how to maybe reuse this kind of pipeline in the future? Everybody following along well? Anybody having any troubles? All right. So spiders, that's probably like the most important part of any Scrapy code is the spider. So here in this sample spider code that I got from scrapy.org, I have highlighted the 2 most important components of a spider. So this block of code on the top first finds the header element in the HTML response, and then it extracts the text from that, and then it uses that text as the title field for this object that's like this object that's in these curly braces. So that's an object, and title is the name of the field, and the value is the text that we're getting from this header element that we're finding from the response that this website gave us that we listed over here. So and then after getting this object, what we're doing is we're yielding it. So you see this keyword yield. It's something that Scrapy introduced. So as yielding in this context means like exporting this object, right? So you have an object, you yield it. Yield just means like export it, like means put it in the CSV file. But the keyword yield can have two different meanings in Scrapy. So as I just said, when you have an object and you yield an object, then Scrapy exports it. On the other hand, when you yield a follow-up link or like an HTTP request or a URL or a link, basically, Scrapy does not export that link into a file. Rather, it adds that link to the list of URLs that it queued up for crawling. So going back to the first thing I said about Scrapy, Scrapy is built for web scraping and web crawling. This block on the top shows web scraping in action because we got some text and we exported it, and it got to some CSV files. So it's like automating the task of me copy pasting that manually. This block on the bottom is web crawling in action because what we're doing here is we're finding the link in the page that was sent to us by this website. So the website responded with the code for the first page. And in the code for the first page, we found the code to more posts, and then we followed up on those. So this is basically web crawling in action, right? So in the bottom block here, basically we find some links and we yield them. So Scrapy will eventually scrape those related links as well. We use the yield keyword in both these blocks, yield and yield, but the difference is that on top, we're yielding an object that we want to export. And at the bottom, we're yielding an HTTP request that we want to crawl. So now, before we start coding our spider, let me tell you how to convert what we saw in the previous slide into code. So as I said, yield keyword, if you pass it an object, it exports it. And the same yield keyword, if you pass it an HTTP request or a follow-up link, then it doesn't export it, but rather it crawls to it. So does the distinction between those two make sense to everyone? Are we good with that? So we got so this is what Scrapy does, right? You can yield an item or you can yield an object. But as I mentioned, we're also going to be using the Beautiful Soup parser. So let me explain some of the functions that are provided by Beautiful Soup now. So after you have converted an HTML response to a soup, now what that means is like Scrapy will give you a response. You copy that into a Beautiful Soup object, and that will turn it into a soup. So wait, somebody said, so crawl is going and yielding, yield is saving. Well, the yield keyword is used in both contexts. It just means that I'm giving Scrapy something that I wanted to do. I want Scrapy to do something with this. I either wanted to export it or I want to crawl that link. And Scrapy automatically determines whether it's going to crawl or save based on if it's an object that it wants to, like if it's an object, it saves. And if it's a link, then it doesn't save it. Instead, it just crawls to it. All right. So talking about Beautiful Soup, once you copy the response into a new Beautiful Soup object, it converts that into a soup. And then from your soup, you should be able to do find all to get an array of elements which match this criteria that you pass in the parentheses. And find one is you find the first element that matches that criteria. And then once you've found an element, you can do element.get and then pass the name of the attribute you want to get. And Scrapy will return the value of that HTML attribute. The next function is the get text. So text is in HTML, text is something that's not stored in attributes. It's something that is stored between the opening and the closing tag. So if you want to extract that part, then you do the get text function. So you can keep this in front of you as a reference while we're coding the product spider. So we're about to get started on that. Everybody please go to the spiders folder and then click on product.py and make sure you get to this file over here. And then if you go to line number 54, you could see your first task. That is to define the search URL format. So what this basically means is, like, let me try to go to Amazon.com and search for gaming PC. And maybe like go to page number 2. And now we're trying to set up like the format for the link. So like, you know, given a specific keyword that is like gaming PCs and a given specific page number, like page number 2, how can I know, how can I generate this link over here, right? So we want to return this link in this function. Now, by default, it has a pass keyword over here. Pass is just like return null. I just added that as a placeholder. So the first thing that you're going to do to this code is just delete the pass keyword from line 55 and return an actual string. So return, and then in the single quotes, you paste this string. I can just copy that and paste that to the chat so that everyone has it. Now, the problem is that this is like a hard-coded string. It already has all the values hard-coded in it. But what I want to do now is I want to replace some of those hard-coded values with like variables. So I have to put an F in front of this to indicate that this is a formatted string, and now I can use variables inside it. But in order to use variables, I have to use curly braces. So the first variable that I'm going to use is the self.base URL. So over here, I've already defined that to be https://amazon.com. And I want to replace https://amazon.com with self.base URL. And then I noticed that after the slash, they have provided some queries over here, some URL queries. First one is K, that probably means the keyword equals gaming plus PC. So that was like the string that we searched, but they replaced all the spaces with plus. And then it has an ampersand to indicate that now we're moving on to the next query, which is page equals the number 2. And then it has some useless queries that we can delete. So I just deleted those to make this simpler. Now we want to replace gaming PC with a variable. So replace that with curly braces, and in the curly braces, we basically want to pass the keyword here, right? And in this context, the keyword is in the key. That is the parameter to this function. So we pass the key here. And then again, similarly, the page number parameter gets passed here instead of 2. So you replace 2 with the curly braces, and you do page number. So we don't have the self.base defined in our code. Self.base URL. Is anyone having trouble reaching here? Somebody said they don't have self.base defined in their code. In the overview, I have it. Looks like somebody's just having trouble finding it then. I'm pretty sure I made sure to include that. All right. So self means we're talking about this class. So this product spiders class. And self is also like, you have to take self as the first parameter from any class member function to be able to access self and all the other member variables that have been defined over here. So basically, this was how we, in web scraping, This is how we go to a website, see what kind of URL structure they use, and then basically use that to define how we're going to make requests. I have done a very similar thing in task number 2 and task number 3 for the overview URL and reviews URL. So you can actually go to a product and look at its product overview page and compare this URL to whatever written over here. And both of these URLs basically mean the same thing. And then for product reviews, I went all the way down to see all reviews. And then I went to page number 2. And then I looked at this URL over here, cleaned out the stuff that I do not need. Left the stuff that I needed. And make sure that the question mark is still there. Oh, I forgot product reviews. I accidentally deleted something, but yeah, you make sure that you clean out the URL, and even after cleaning out, it still yields you the exact same link. Then you can copy it into your function, and then you can replace parts of the hard-coded URL with like, the variables that you have available to you. So next up, the start request. Scrapy calls this function at the beginning of the crawl. So when the crawl starts, we want to give Scrapy a bunch of URLs to work with, or at least the beginning 3, right? So we're going to search for mechanical keyboard and mechanical mouse and gaming PCs. So at least the search pages, the first search page for each of these keywords, at least that part, we want to start with when Scrapy starts the request. So what we want to do here is yield a search request for each keyword. So delete the past because we're actually going to do something here. So delete the placeholder and then do a loop. So for each keyword in the self dot keywords, I'm going to say yield a request. So this point, we don't have any data, so we're not exporting any objects. We're yielding links to crawl to them. So yield request. And then within this request, it would need some parameter. We need some parameters to build this request. I'm going to say it's URL equals the search URL function, but it's like on self. So I'm going to have to say URL equals self.search URL. So we've already made some functions that return URL for a specific kind of request. So for the search request, we have created the search URL function. It tells you what would be these what would be the URL to the search request, but it needs some parameters, right? It needs key and page number. So to key, we're gonna pass our keyword. And then it asks for page number. We're just gonna say page number 1 because that's where we want to start at. And then optionally, you can provide it a callback function. So by default, there's only one parse function in Scrapy, but here we have created like multiple parse functions. So it's quite ambiguous as to like which parse function Scrapy needs to go to whenever this kind of a request is made. So we can explicitly define that by saying callback equals the name of the function. So that will be self.parse_search. And I missed the comma over there. Make sure you add a comma after every parameter, otherwise it'll give you errors. And then, so if you're passing it a callback function, well, this callback function and actually all our callback functions basically take some additional parameters, right? Like keyword and page number. So you can also pass those parameters to these callback functions by using the callback that is CB underscore KW arguments. That's args. So CB underscore KW args equals like a dictionary of arguments. So DICT to create a dictionary, and then parentheses, we're gonna provide the callback. We're gonna provide these two parameters in this dictionary. All right. So we need to provide the keyword argument. In this case, that'll just be the keyword, the variable keyword that we're looping over. And then parse search also takes page number. So we're gonna have to say page number equals, well, we're starting with page number 1, so I'll do page number 1. And this is complete now. So yay, we did task number 4. So when you do this, now Scrapy will call the start request function, and it will, for every keyword that was in this array, it's gonna yield a request. So you can take your time copying this. I'm also gonna run this to make sure that everything is working and that something's starting here. You know, I'm not getting any more errors. You all can try that too. I'm also gonna go ahead and push the finished code for this workshop into the GitHub repository, so that in case any of y'all are having trouble following with the tutorial, you can just look at the code and then copy from there and follow better by referring to the finished code. So I'm just gonna push that. And now if you refresh the GitHub repository, you should also be able to see the finished code. So maybe if you made a little mistake copying anything from here, then you can just go to the GitHub repository, open the finished code, and see the final finished code. But since we're running out of time, I'm gonna move on. Unless anybody has any questions. No? All right. Were you guys able to at least find the finished code in the repository? Oh, I'm not sure if it got pushed completely. Yeah, it should be good now. So you should be able to see the code that you started with, and there's another folder which has finished underscore code. So Christopher, you said no module named Amazon scraping. I'm not sure what's wrong, but I think there's a good chance that maybe you didn't open the correct folder. Are you in this folder that looks like this, or did you maybe open a folder that was above this or below this or something? Make sure that you open this very exact folder, and then you shouldn't have any errors. So I'm gonna do to-do number 5 real quick. Task number 5. Can you post the final code? Yes, I have posted the final code in the GitHub repository under finished underscore code folder. And this has the Amazon scraping code that we're using right now. And it also has the code for Seaborn that we're going to use very soon. Push the changes to master, please. I think it should be in master. But yeah. Let's get to task number 5. So we want to do find all search result items in soup. So let's store the result in items equals, as I said in the slide, soup dot. Now what we want to do is search all results. So we're going to use the find all, not the find one. And now we need to pass it some criteria. You can pass it like the CSS tag or something, but the thing is that Amazon is not really consistent about their CSS tags. So it's basically like they probably use a framework or something that generates it for them. But there's one thing that was quite consistent across Amazon that is actually something that frameworks use very often is like these data hyphen something attributes. So these are HTML attributes that are not like defined by any standard. These are just like for people to create their own custom HTML attributes. And they have said data feature name. So they've said this feature name is title. So that's pretty much how, that's basically how Amazon is doing it. So we're going to find stuff by their HTML attributes. Let's try to go to the search page because that is the one that we're trying to scrape at the moment. So there's basically a bunch of different products, right? So each of these should be in like a different division. And then I noticed that this division had the data component type set to S search result, and it had its data ASIN set to the product serial number. So that is very good for us. And we can use that to tell Scrapy the criteria. So we're gonna say ADTRS, that is like the HTML attributes. And here we're just gonna say that find all that have their basically, data component type set to search result. So if y'all have never done scraping before, those are pretty much the two main components, like figuring out how to get to the links and figuring out how to get to the data. Now that you have the objects, here's what we want to do with it, right? We want to yield requests for each item found. So items here, as I said, find all returns an array, so or like a list. So items would have like a list of objects. Let's iterate over them. So for item in items, we're gonna do the ASIN equals item dot get key equals data ASIN. So as I pointed out, all the search result items had their data component type set to S search result. That's how we're able to find them. And then all of them had their data ASIN set to their ASIN. So from that, we're able to extract the ASIN of that product. And if we were successful in finding the ASIN, that's good. That means this was a valid entry, and we're going to reject the invalid entries. But if it was a valid entry, then we want to do two things. So we want to go to two pages. We want to go to this overview page from where we can get its title, its cost, and its average reviews. And we want to go to its see all reviews pages from where we can get its individual reviews. And I've already programmed the I've already written these two functions, the overview URL and reviews URL, as I said, similar to the search URL that has the URL functions, and we can use those to create requests. So requests would look pretty much like this. So I'm just going to copy it, paste it, and then modify it. So we're yielding a request. We're no longer doing for the search URL. We want to do for its overview URL. So I'll go overview URL. And the overview URL function, let's see, it only takes a key, right? And in this in this case, the key is the product ASIN. So we're going to pass it the product ASIN. And then callback equals, so key equals ASIN and callback equals not parse search, but there's a different parse function that we want to use for overview URLs. So parse overview. And CB KWArgs, we're going to set parse overview. Sorry, we're doing parse overview. So it needs ASIN and it needs a keyword. So those are the two parameters that we need to pass to the callback function. Sorry, I messed up here. So we had ASIN and keyword. Yeah, good. So ASIN here is the ASIN variable that we just extracted. And keyword is like the keyword that we used to get here. So that is something we're not extracting here, but that was already passed to us. So I'm just going to say keyword equals keyword. And we got this request to go to the overview page and then parse it using the parse overview function that we define here and pass these two arguments to the parse overview function that are needed. Similarly, I'm going to make a request for the reviews. So as I said, I want to go to this overview page. That part done here. And then I also want to go to its reviews page. So now I'm going to change this function over here to the reviews URL. So I'm going to change in the second request, I'm going to do reviews. And then the callback for that would be self.parse_reviews. And then the self.parse_reviews takes ASIN and page number. So I'm going to go here and have these two defined. ASIN equals, I'm going to say ASIN and page number equals 1 because whenever we find a product in the search page, we want to go to its first reviews page, right? There could be like page number 1, page number 2, 3, a lot of pages of reviews. We initially just want to go to page number 1, and then from there we can, crawl ahead. But for now, we're just going to go to page number 1. Now, basically, till now, what we've done is we were looking at the first page, right? And we were just, for that first page, we were finding all the different products, and then we were crawling to those products. What we also want to do sometimes is go to more pages. So if you search gaming PC, this is the first page you get. Right now, if you compile the code that you have, it should be able to export or at least crawl through. It should be able to crawl through all of these products that you see on the first page, but nothing that's on the second page. So we want to have a code for that as well, for that once you're on this first page and from there you want to go to second page and third page and so on. So let me do that real quick. We'll only do that if some items were found. If no items were found, that means it was an invalid page. We've hit the last pages. We don't want to go forward anymore. We're done. Another condition that could prevent us from going forward is what if we've reached our limit, right? So I've defined max search pages as 3. So this bot will not search for more than 3 pages so that we don't have like too many requests going out to Amazon. So next page number, I'm going to say that equals the current page number plus 1. And then I'm going to say if the current page number, the page number is less than or equal to the self.max search pages that I said that our bot should be able to scrape through, then it's fine. Then we do something. Otherwise, we don't, right? So if no items are found, we don't crawl further. If we've already reached the limit, we don't crawl further. But if neither of those true, then we do crawl further. So how do we crawl further? Now here we're going to make like a recursive request. So we're already in the parse search function, but we're going to make a request also to the parse search function. So it's going to be a recursive request, and its format is going to be very similar to the one that we had in the start request, because this is the one that we were making for search pages. URL would be search URL keyword, and then we got page number 1. So in the start function, we were just passing page number 1. Here, we're actually going to pass the next page number, which would be page number +1. And here again, we'll be passing that thing. So if you were able to follow up on here, I think the next one, parse reviews and parse overview, should also be pretty easy to understand. And I've already uploaded the finished code, and it's getting pretty late. So I think I should try to wrap up here. But basically, after you're done finishing your code, or if you open the finished code and you hit the build command, then your output directory would start filling up with these CSV files. And once you do that, you should have all the outputs. It might take about 5 minutes, but you'll have the outputs, right? So thank you, everyone. You did a great job. You're done working with Scrapy. Now I would like to pass the mic to Alex.
Hello there. Can everyone hear me?
Yes.
Okay, that's good. So I'm going to share. Before that, I'll talk a bit about Seaborn and what it is and why you should use it. So basically, what Seaborn is it's a data visualization library in Python, and it is pretty powerful. The other visualization libraries are very good, but I think that Seaborn has a lot more options, and it's a lot more optimal for what we're trying to do. The reason why we decided to do data visualization with today's data mining workshop is because I believe that every data scientist or any scientist worth their salt should be able to more or less be able to show the results and graphs. So I'm going to start off by introducing y'all to Google Colab. Let me find the correct, I believe this should work. Does everyone see me sharing? I hope. Okay, perfect. So if you'll type Google Colab in Google or DuckDuckGo or wherever you are, so what it will take you to is this page. And if you're signed in with Google, or if you're not signed in with Google, sign in. And I'll take y'all to, it will take y'all to Google Colab, and then we shall do some data analysis. So the first couple of things that you need to do is to import pandas and Seaborn. And for those of y'all who don't know Google Colab, it's mainly in Python, and right here is a code cell. So if we want to put in some Python code, all we do is put it in the code cell. So import pandas and import Seaborn as SNS. I may turn off the animations in case they make everything slow down, but I'll leave it on for now. And also the reason why I switched on to Google Colab, I don't remember if I mentioned it, but it allows you to first of all, share very easily on Google Drive. And also it's you don't have to download everything. Like you don't have to basically make sure that your packages are up to date. Everything is going to be up to date. And all you have to do is import stuff into Google Colab. Now, I'm not sure if y'all were able to finish up your code. So the next step is going to be very important. Let me see if I can attach something here so that you guys can get this. Let's see here, sticker format. Can I put in something in the chat? Okay, it doesn't allow me to put it in the chat, but if you go to GitHub, you're going to be able to basically access the CSV files that Ishpreet was able to generate, or you were able to generate. And what you do with the CSV file, you can download it and you can upload it to Google Colab. And you do by going to this icon here that says files, and it's like a little folder, and then you just upload the data. And so the data that I have, or that I will be using, is Mechanical Plus keyboard. So, and it shows a reminder that it will basically delete itself once the runtime is off. So just in case, for this purpose, it's okay to just upload it just this once. But if you're constantly working with a file, it will be a good idea to put it in Google Drive and then just mount it onto your Google Colab file. And from then on, it will be a lot easier. But for this purpose only, we're going to attach it to here. So the next step is to create a new code cell. And we're going to import the file into a data frame. So we do df, which is data frame, equals pd.read CSV. And the next thing, which is a small little trick that you can do, and this is whether you have Google Drive mounted or you just have a normal file, you copy the file path. So you go here and you copy the file path of your file and you just insert it in here. And if we did correctly, it basically imported the CSV file to the data frame. And we can take a look at the data frame here to make sure that we have everything correct. And as you can see, most of the stuff is correct. The only slight difference is that the average stars on some of the files might be capitalized depending on what syntax you use. Right here, I have it capitalized. So for the next steps, just keep in mind if your file is lowercase or uppercase. So then we have one code cell and we're ready to begin our data exploration. Now, the first graph that we're going to do is this. Yes, thank you, Ishpreet, for putting that in. For some reason, wouldn't allow me to put in the CSV file, but in case you don't have this CSV file, it's in the chat on Microsoft Teams. So can anyone tell me what this means, or in theory? What kind of plot this is? Somebody has an idea. So reference, this is a distribution plot. So a distribution plot will allow you to see kind of how your data is distributed across several values. So if, for example, we want to see the distribution plot of average stars, that's basically what we put for X, which is going to be our bottom axis, or our x-axis. And our y-axis is going to be the count. And yeah, also one more thing before we actually run this code. we also want to do this thing here called set theme. And basically this sets it to a default theme, and it won't make your graphs look weird, which can happen whenever you use some of the other graphing libraries. And I can actually show you what will happen if we do it like this. So it will plot it like so. So here's kind of your distribution plot, and it looks okay, but the main problem is kind of that these two parts are, or at least here it's going to be black on gray, and we optimally want to make it look a little bit better. So if you want to polish it up, we can just set the theme, and we'll make it look a bit better. Yeah. And the cool part here is once you generate this graph, you can basically just copy the image or save the image, and you can put it in your paper or PowerPoint or wherever you want. So that's kind of the cool part about it. As you can see, we have a pretty normal distribution. And if we want to enhance it even more, we can do we can just copy this. And at the end, we can add KDE, which will make it true. And KDE stands for kernel distribution estimate. And basically, it just estimates around where how your normal distribution is, and it will make this nice line graph, which is looks good in terms of results. Did everyone follow that, or I don't see any responses or any questions? So just want to double check if you all are following. Okay. I'll take that. Okay, good. I'll take that as a yes. That's good. So the next part, we can also do the distribution plot for the price as well. And we can just copy this part, paste it here, and we can change this to price. And so we can kind of see from here that the price for the most part, it falls like around under $60 for mechanical keyboards. And then later on, once the price increases, we have less and less since people don't want to buy more expensive keyboards. And here also, you can kind of see that the distribution is in between 4.2 to 5.0. So you can make what you want of it. Mainly, I think that the keyboards are quality more or less, and that for the most part, the customers are satisfied. And these are average reviews, by the way. It's not just one single review. They're average reviews for several keyboards, if you remember the CSV. So for the next part, we can do a relation plot. So it will just plot price against average stars. So we do it by doing rel plot, which stands for relational plot. We select that data equals the data frame. X is going to equal to price, and Y is going to equal to average stars. And we can see that we can see the relational plot, and we see that there seems to be some linear relation between those two. And we can also, if we want to see if we can actually if we can get a line, we can just add this option called kind equals line, and we'll try to graph these as a line. Yeah, I need to add a comma here. There we go. So you can see it kind of increases. There's some random bumps here and there, but aside from the outliers, it seems to increase more or less. And so for the final part, we can do this kind of plot. If anyone is listening in the chat, you can try to guess what this stands for. So for those of you who don't know, this stands for linear model plot. Yeah. Yeah, so for linear model is basically when it's the estimation of x against y. So in case you have these points here, it tries to basically get the best estimation out of these plots, out of a plot. And it can be done for polynomials, but in this scenario, we made it a bit simple, just x against y. And there's also a class that people for the data science degree have to take called Apply Linear Models that just talks all about how to make linear models. But in this scenario, we just make it very simple. And we say that data equals df, x equals price, and y equals average stars. And if we run this block of code, as you can see, we get a linear model. And the cool part is that Seaborn automatically also puts in the confidence intervals, which are basically intervals where you have like the most important points which form this line. So it found more or less the linear model. It ignored kind of the outliers more or less and formed something. So yeah, that's about it. And for Seaborn, this is kind of like very elementary kind of data exploration and analysis. In case y'all find any other interesting ways to use the data from web scraping and find some new insights, just put it in the Discord and we'll give you all a shout out, maybe on Instagram or LinkedIn. So yeah, that's basically it. For reference, all these graphs are in PowerPoint, and I believe there's a file in the GitHub. So if y'all weren't, if y'all didn't get Google Colab working, or I was a bit too fast, everything is there for reference. So yeah, that's it. Thank y'all for coming. Ishpreet or Guangze, if you want to take over and show the last bits. Yeah, awesome. There are a couple of slides I believe we wanted to show y'all. Let me see. In theory, you want to show these slides when there were a lot more people, but I hope everyone still can see this. So yeah, in case y'all want to explore a bit more for Scrapy or Seaborn, we got these links here. I think the PowerPoint will be provided on the GitHub, if I remember correctly. Also, some important information. There's going to be an introduction to data analysis on February 23rd. And if you're in the ACM Discord, you're going to get the information there. There will be an ACM Education Hacking the Hackathon talk on the 24th of February at 7. And in case you haven't signed up for HackUTD, please do so. Yeah, thank you all for coming. There are 2 dates on the slides for the intro. Is it the 23rd? Yeah. Thank you, Camden, for answering that. If also you want to drop a couple of words, Camden. Camden is the HackUTD president, for those of you who don't know, or director.
Yeah. Thank you guys all for coming out. We've really prepped hard for this workshop, and we're also glad that you guys came out. We're really excited to see you guys at the second part of the second workshop that we'll be hosting of this series, which will be on February 23rd. And then right after the 23rd, on the 27th and the 28th will be HackUTD. And on we'll have more workshops catered to other phenomenons of we'll have other workshops essentially catered. So if you guys are interested in learning more at HackUTD as well. So if you guys are interested in signing up, go ahead and sign up on our website. Again, thank you guys so much for coming out, and we hope to see you guys at our future events.
Thank you.
Yeah, thank you guys. Does anyone from the HackUTD team have any last words before we're done?
No, just thanks guys. Thanks everyone that came out and actually stuck it through to the end. So.
Yeah. Thank you guys. Our next workshop, as mentioned so many times before, is in about 3 weeks. So yeah, we'll be posting announcements for that. Other than that, the recording will be posted in the Discord, and the finished code's on GitHub. So if you guys want to go through the workshop again, you guys are free to do so. But thank you guys for coming. Yeah. Have a good night.